All right, we're starting. Okay, so basically we're going over prefix sums today. Prefix sums, I can't say they do anything that like you can't already do, but the entire point is to usually speed up like some operation that will like require you to check a whole range. Oh, your mic's setting off, Jason. So basically, what a prefix is it's exactly like what you know, like in English, where like I don't know if you have like some word like I don't know, like I told Omar like obtain, right? You can put a prefix in front of it, like un. So basically, like a prefix is just something that goes like from the beginning and then onwards. So I'll just start by just drawing out a prefix sum array. So let's say we have the array I'm gonna draw 4 cells instead. So let's say we have an array of 4 elements, and we have, let's say, 8, 3, 1, 7. So this is just your array. So the corresponding prefix sum array would be 8, 11, 12, 19. So as you can see, basically what the prefix sum array is you get the sum up to like the given index. So at this first index right here, we have the sum just up to index 0. For this index, we have it going for the first 2 elements, for this one the first 3, and then so on. So basically it's pretty easy to make. You just have like a variable that stores the sum, and then you increment it by if this is array like a, you increment it by a sub I, and then set like your, I usually call my prefix sum arrays like p. So you would just increment your sum by a sub I, and then set p sub I to equal the sum, and then keep going. So the entire point of the prefix summary, like I said, is it's not going to help you do anything that you can't already do, but it's going to make you do it way faster. So, the most important thing that it does basically is it'll retrieve the sum within a given range in a constant time, as long as you've already created this prefix summary. So in order to create the prefix summary, the time complexity will be O of n, because you have to iterate through each element of your original array. But once you have this, you can get any range sum you want in O of 1 time. So let's say let me index these. So I'll one index them to make them a little more convenient. So here's our indices. So if we wanted the sum from 1 to 3, we would have 8 plus 3 plus 1, or 12. And you'll notice that's just right here, right? But let's say we want something that's not from the start. So let's say we want the sum from 2 to 4. So this segment right here. So that would be 11. So 3 plus 1 plus 7. And how can we get that using this prefix sum array? Well, we know that if we take this element right here, so this 19, this would be the sum from the beginning all the way until the end. So we would have 19, but we don't want this segment. We want this segment right here, right? This smaller one that doesn't contain the first element. So what we do is we just go ahead and subtract the part from the beginning that we don't want. So what we would do is we would take the 19, and then we would subtract everything before it, so this 8. So if we do 19 minus 8, you'll notice we get the 11, which is what the sum of this segment is already. Does that make sense to everyone so far?
So far,
Yeah.
so good.
Yep.
I have a
Omar
question
accent.
though.
Oh, this
What
is
if
gonna
like
be a
the
troll.
array, the original array updates?
Oh. Um. Oh, if you're like, are you saying if you like increment it over a range, right?
No, like
Or
one
a
of the
point update?
indices gets removed or something.
If you change the size, if you change the size, I don't know how to do that. If you're changing a certain index or changing the sum over a range, you can do that. So I'll go into this literally like right now. But the good thing about prefix summary is you can also do range updates, like a bunch of updates in O of 1, and then just process it at the end. That's a problem that Omar actually had to solve like yesterday and didn't get. But if you're like literally removing elements, then you can't generate a prefix sum array because the size of the array is different. Um, there are two different problems though if you're not talking about like editing the size. If you want to edit any of the elements within a range, whether it's a single element or a range, because like if you can edit a range, you can edit a single element. If you're asking like what if they want you to edit a range and then they want you to print the array and then they want you to edit the range again and then print the array, or like if they just give you a bunch of edit commands and you print the array once at the end, those are two entirely different problems. So if you have to edit the array and then print like an index, you solve that with segment tree. If they just give you a bunch of um, range updates all at the beginning and then you just print the array once at the end, then you can do that with a prefix sum array, which is a problem that I actually have on Cody for later. So so if this is basically what we can use prefix sum for, like kind of getting the sum between a range, then there's all kinds of applications that you can use it for. So like an example would be like let's say like you had a problem where like you have some array like of this top one right here, and you're allowed to take consecutive elements, like maybe k consecutive elements. And let's say like k is equal to 3. So k is equal to 3. So you can take any three elements in a row, and let me just expand this array. I don't know, let's add two more elements. So let's do 4 and 5. So let's say like a problem wanted you to take you wanted to see what's the maximum sum you can get if you can take three consecutive elements. So if that was the case, I'm gonna delete this. So you would take the maximum between this segment, this segment, and this segment. And if you just run a for loop from the beginning to like the end of your segment and add them one at a time, the time complexity is gonna be n squared. So it's gonna be really slow, right? So instead, what we would rather do is we would generate a prefix sum array and then just take the sum on this range in O of one, then this range, and that way your program goes in in linear time instead of n squared. Of course, you might have noticed you could just use sliding window instead, but there are cases where you do want to use prefix sum. And what I mean by sliding window is instead of like generating your prefix sum array and getting this range, then this range, then this range, what you would do is you would directly calculate this sum only, so the first three, and then what you would do is you would subtract this, and then you would add this, and that would help you calculate this range right here. And then when you're going for the next one, you would cut off this one, and then you would add this one. So that way you're not calculating uh the entire like range completely. You're only removing one and adding one, so the time complexity is still linear. So if we're gonna go into one of the more like trickier but a lot more like useful applications of prefix sum, it was in a problem that Omar did yesterday, which I'll go over after we do it on the whiteboard. But let's say you have a problem where you have an array that's this is, to be honest, like quite literally what I wrote on Cody, so you'll have this to solve later. So let's say you have an array and initially the array is just full of zeros, right? So let's say let's make an array of size 5, and let's just have everything start off at 0, right? And you're given a bunch of operations in the form x, I'll draw it over here. So in the form x, l, r. So basically what these operations will mean is on the range L to R, increment every element by x. So if I, for example, do 3 to 4, this means increment every element from index 2 to 4 by 3. So if I one index this array, just to make it a little more convenient. So if we apply this operation, so increment everything from 2 to 4 by 3, then everything in this range becomes 3. And let's say we do another operation, so let's increment everything from 1 to 2 by 4. So these two would get incremented by 4, so this would become 4, and this would become 7. So let's say you're given all of these operations up front and you want to output what the array is at the end. Now what you could do is for each of these operations, let's say you're given a bunch of them, like 10 to the fifth or something, you could start at here and then iterate here, like using a for loop and literally like adding them to each index. But once again, the problem with this is like it's gonna take a long time. Total time complexity of this is gonna be n squared again. And with prefix sums, there's a way we can solve this in O of n and get each of these operations down in constant time each. So I'll leave this here. Actually, we'll do one more operation to, let's see, let's increment everything from, I don't know, 4 to 5 by 2. So now this will be 5, and this will be 2. So I'll leave this here, kind of as our like answer. So what we're instead gonna do, instead of writing like a for loop that takes us from L to R, we're basically gonna update only two indices that reference the end and the start point of each of these segments. And then we're just going to iterate through this new array we've created just one time once we've processed all of these. So using a prefix sum, what can we do? So these will all start off at 0. And what we're going to do is we're gonna instead of literally, I'll just write the indices out again. So 1, 2, 3, 4, 5. So instead of so if we process these ones, the first operation we need to process is increment everything from 2 to 4 by 3. So instead of going through 2 to 4 with a for loop, what we're gonna do is we're going to increment our starting point by 3, right? So we're going to change this to 3 or add 3 to it. And then we're going to go 1 after our endpoint, and we're going to subtract 3. And what this is going to do is when we do a prefix sum on this array, so we start our sum off at 3, or at 0, sorry. And then what we're going to do is we're going to add each cell and then set it as we add that number to our sum. So obviously if we update range 2 to 4 by 3, we end up getting oh wow, that's really small. But what we get is 0, 3, 3, 3, 0. So basically, everything in the middle is a 3 and the end ones are zeros. So if we apply a prefix sum on this array, what's gonna happen is uh, we're going to have our sum start off at 0, and then we're gonna add this 0, and then we're gonna set this cell's value. So this is literally like our final array. So what it's gonna end up as. So this cell will end up being a 0, and then now we're gonna add this cell, right? So we're gonna add 3 to our 0. So now we're at 3, and then we're gonna update this cell. Once again, we add 0 to this 3, so we're still at 3. So we'll fill this one as 3. We'll add 0 to this, to our sum again. So we're still at 3, and then we fill this in with 3. And then now we subtract 3 from our sum, and we're at 0, and we fill this in with 0. So do you notice how we actually get the same exact resulting array, except instead of writing a for loop, we we fix this update by only updating the starting point and then subtracting this value from one after our endpoint. And the reason this is going to be like really helpful is here we only change two values, right? Once again, the beginning and one after the endpoint. So if we had to update a range from like, I don't know, like 1 to like 100,000, we wouldn't have to iterate through 100,000 array elements. We would still be only changing two values. So this is going to come in handy when we're processing all of these indices, right? So what happens is instead of taking the sum like I have right here, we're gonna go ahead and continue this technique of incrementing index L by 4, and then incrementing like our right endpoint, or we're gonna subtract 4 from 1 after our right endpoint. So we've already went ahead and set it up for this first one. So if we do it for the other two, so increment everything from 1 to 2 by 4. So we're going to add 4 to index 1. And then we're going to subtract 4 from 1 past our right endpoint, because we only want to increment 4 from 1 to 2. We don't want it to apply on anything past 2. So we're just going to subtract it on the index after. So now we're at minus 4. And then for this last query, from index 4 to 5, increment everything by 2. So we're going to add 2 to index 4. and then we would subtract 2 from the index after 5, but you'll notice that goes out of bounds. So you could write an if statement, but my recommendation would just to be to initialize like the vector like with one more element and then don't even bother using it. So I mean, we're not gonna technically even access this, but I mean, for the sake of doing it, this would be -2. So now let's go through let's generate our prefix and see if we get the same thing. So once again, our sum starts off at 0, and then this will be our final array. So let's do this. And then so let's fill in this array and we'll see if we get the same thing as this, right? So we have 4, so we're gonna add 4 to our sum, so our current sum is 4, and then we'll fill this in with 4. Now we have 3 here, so we have to add 3 to our sum, so now we're at 7, and then we fill this in with 7, and then now we get -4, so we have to subtract 4 from our current sum. We get 3, fill this in with 3. Um, this index is 2, so we add 2 to our sum, now we have 5, fill this in with 5. Um, Here we subtract 3, so 3 minus or 5 minus 3, we get 2. And then once again, we could process this, but this is just like some arbitrary endpoint we don't even care about. So if you notice, this matches the same array that we generated, where like in this example, I literally went ahead and started at 2, went until 4, and then manually added 3 to all of them, from 1 to 2 and added 4 each time. But the pro to this one, right, is once again, we're not iterating from the left endpoint to the right endpoint. We're just changing only 2 cells. So once again, this will allow us to generate the calculated array in O of n total time instead of n squared. Because the main thing to take away from it is like, let's say I draw out a really bad case, right? So let's say you want to increment everything from index 1 to 100,000, um like by 2, and then increment like 2 to like 90,000, everything from 2 to 90,000 by 3, and then so on. It's going to take you so long to iterate from this endpoint to this endpoint. It's going to take 100,000 operations to do this, and it's going to take 90,000 operations to do this. Whereas with our prefix sum trick, we only change 2 indices and then we handle it at the end. So um, this way you can solve problems like in linear time, or you can process all of these operations in a second. Whereas if you write a for loop from here to here, you're not going to be able to. So are we all good on this?
I think so.
I think you already knew it though.
Yeah.
Anch,
Yeah, it's
Jason.
good.
Yep.
So like the main point of this is if you have multiple operations, right? Because if you just have like one of
Just
those,
one, then there's no point. You would just
yeah,
go ahead and do it, right? So yeah. And like I said, it seems kind of weird thinking of it as like, why would we have multiple operations? But once again, there's going to be a lot of problems where like you have to take like the sum between like, I don't know, this and then this and then this. And like you don't want to have to like calculate that like in O of n time each time. So what you instead do is make this prefix sum array and then just generate the sum on that range in a constant time. So it's pretty easy to understand like why it would be really important to find like the value of a range in like a much faster way than iterating through it. So, if that is the case, let's move on to my computer. So I'll go ahead and stop. My camera's off, so head onto my screen. So so now basically I won't actually code it for you, or the second part, the harder part, because that's a problem that I'll leave you guys to do after. I know Omar and Anch probably want to do it because I put it on a contest for them yesterday. But basically, if you want to know how to make the prefix summary, let's say I have some like array, um, and I don't know, like it's two. I mean, what do I have on the board? Let's say 4, 7, 3, 5, 2. So if you want to make the prefix summary, so like prefix, I would initialize it with size. This is 5 elements. And then once again, you would start your sum off at 0. And then you iterate through the entire array you add the current value at this array, and then you set your prefix sum index equal to the sum. Make sense? How you make this prefix sum array? Pretty straightforward. You just, once again, have a sum that starts at 0. You just add each element and then set it in that prefix sum array. So yeah, that should be all you need to solve the Cody problems. If you're new, this is the website that we use for like practice problems and contests. If you've taken a class with uh, Dr. Lair or maybe Conrad, I don't know if Conrad's ever used Cody, but a lot of professors at RCC use this, so you might have an account anyways. But here are the problems for today. They're just bunch of prefix sum problems. As always, we'll go over the solutions afterwards. And if you knock them all out, I've got 2 extra problems for you on websites that aren't Cody. So, any questions before we start?
No questions.
Which competition is it?
20. The last one on the list. So, all right, I'm gonna stop the recording.